So continuing on with our similar triangles, we are going to get a couple of special relationships that appear, and it's going to be within right triangles. So the big thing here is we need to make sure we have right triangles. I've seen this referred to two different ways, either the mean proportional or the geometric mean. And we're looking at two positive numbers. So it says geometric mean of two positive numbers, a and b, is the positive number x. So in this formula here, notice what they're saying. They're saying that x is what's considered the geometric mean. And when we solve this, we'd have to cross multiply. So how we get this would be x squared equals a times b. So in order to undo that square, that's where that square root's coming from. And so we would get that answer. Okay. Sometimes we call this the means and the extremes. It says, remember the rule for working with proportions, the product of the means, because remember cross multiply, is equal to the product of the extremes. And think about what they're saying. The product of the means, that's your geometric mean. That's some number in between your two extremes. So these extremes, the a and the b, should be a big number and a small number, and this mean is a number somewhere in the middle. Now, not our typical like average mean added up and divided by the total, but a geometric mean, which is coming from different proportions. So it says here the altitude, and this is our altitude, forming a perpendicular line. Of a right triangle, it forms two different angles, or two different triangles, and they're similar to each other and to the original triangle. So notice how it's written. Triangle ACB, so that's our big triangle. Triangle ACB is similar to, now we get two smaller triangles inside. Triangle ADC, that's like our medium triangle, and then triangle CDB. Start at C, go to D, go to B. And if you saw the way I trace those out, you can see that that order has kind of flipped around a little bit. One way to perhaps organize this in your head is to maybe label the sides. So for instance, if I were to look at the triangle, let's say this first one, the way that they have labeled this, it's going from the long leg, AC is your long leg, CB is your short leg, and then if I were to wrap it around A to C, that's long leg, C to B, that's short leg, B to A, going this way around, right, as we're labeling it, that's giving you the hypotenuse. So if I look at the other triangles, the way that they've listed them out, so we go A to D to C. So it should go in that same order, long leg, short leg, hypotenuse. So A to D, I see that's my long leg of the black triangle, D to C is the short leg of the black triangle, and then C to A is our hypotenuse. And it would work the same in the blue triangle. So sometimes it gets a little visually challenging to try and get these pictures to line up. I've tried to give you some examples of how these would actually match up. And this right here is our starting point. That's kind of like what we had up above. And I can see the three triangles that they have pulled out. ABC is your big triangle, and ADC over here. Okay, so this one they've taken from this side. They've kind of said, let's reflect this. So if they reflect it over maybe perhaps line CD, that's how we're going to get this triangle. And now I can see how my angles are matching up and my triangles are similar. And now this little guy, we have to do two things. Not only do we have to rotate it, but now we're also going to have to reflect it. So let's say I reflect it over DB first, and then I'm going to rotate it around so that they are situated. Okay, over here, same idea. Here's my big triangle. We drew in the altitude. I can see I have the big triangle itself, light blue, dark blue, and once they've rearranged them, I can see how they're all similar. It does get a little visually challenging when we're looking at this. So on the back, what we've tried to do is kind of break it down. I like to refer to them as picture 1 versus picture 2, because we get some proportions. And this first one, this is comparing, I'm going to say, our middle triangle and the small triangle. And if I can remember this idea, this formula right here, it kind of saves me from having to twist and flip and rotate. So it's saying if I take this left side over the altitude, it's in that same proportion as the altitude over the right side. We'll play around with this in class a little bit too, so we can visually see how these sides match up. I like to refer to this as picture one. Some people call it other things. The leg altitude adjustment, I guess. I like to call it picture one. Just it's the first picture we drew. Another way that we could map this out, now this would be like, say, comparing big to middle triangle, if I look at the picture on the left. And notice what we're comparing here, the hypotenuse to the leg, and the leg to the part of the hypotenuse that touches that leg that we're using. Okay. This one, same thing, but we're comparing the big and the small, because we said all three of those triangles to begin with are all in proportion. So again, I like to call this picture two, just so we have something to refer to. But if we can kind of memorize these pictures and memorize these formulas, the process of this becomes a little bit easier. Okay, so looking at this example number 2, I'm looking at the parts that are labeled, and it says use the similar triangles to find the length of the altitude. Okay, so I'm noticing here, since this altitude in the middle is labeled, this to me looks like a picture number 1. And picture number 1, if we scroll back up to the top, is saying we're going to do the left side over the altitude equals altitude over right side. Okay, so if I go back. So left side over altitude equals altitude over right side. Now we have our proportion. So that's just avoiding the idea of needing to flip and twist and turn and rotate triangles. Okay, so we can cross multiply. So 9 times 4, I get 36. P times P, we get P squared. And to solve for P, undo that P, we square root it. And keep in mind, you get 2 values, plus and minus 6. But I can't have a negative distance, so we're only taking that positive 6. Okay, number 3. So I'm looking at this triangle, and again, I want to think, is this a picture 1 situation? Is this a picture 2 situation? And it's telling us we have to find the lengths of BC, so I'm going to label that P first, and I have to find the lengths of AC. Okay, well, keeping in mind what we have this entire length of AB. I have the whole hypotenuse. I have to find P. I have the altitude. I could represent perhaps AC as being 53 minus P. And now I have everything that I need to solve using a picture, again, 1 type situation, because the altitude is labeled. Once that altitude is labeled, it's telling us we're using picture 1. Okay, so we're going to set up the proportion. So I have 53 minus P over my altitude equals the altitude over the right side. So we need to cross multiply in order to solve. And when we do this, we have to be careful. Now this is going to get a little difficult with our algebra, but we can do this. So 14 times 14, we're going to get 196. Over here we have P times 53, so there's 53P. And then P times negative P is negative P squared. So I have a squared term, I have a term to the first power, and a constant. And anytime I see one of those, I always think, let's get it over all onto one side of the equation. So I'm going to add P squared over here. And then I would subtract that 53P on both sides. Okay, so that leaves me with P squared minus 53P plus 196 equals 0. So we have to factor. We need to find 2 numbers that are going to multiply to be 196 and add to be a negative 53. And those 2 numbers are going to be negative 49, watch your signs when you're doing this, and negative 4. Okay, so we take each of these factors and set them equal to 0, and what that's going to tell me is P equals 49 and P equals 4. Okay, so how do we know what P is? Well, we could look at the picture and say it probably makes a little bit more sense that P would be 4 if this picture was drawn to scale. But let's say P was 4, so how do I figure out what AC is equal to? Well, if AC is represented as 53 minus P, so minus 4, look at what you get. You get 49. So that means one of the lengths has to be 4, one of the lengths has to be 49. And we did that all by using that picture number 1. Okay, and then we're going to take a look at number 4. So again, I'm going to start us off and say, let's take a look at that segment labeled as H, because so far that's what we've been doing. H is our altitude. And it looks like we would be, again, using picture number 1. So number 1 to solve for H. Okay, so we're going to go right side over the altitude equals the altitude over the left side. And we'll cross multiply. So we get H squared is equal to 14,400. And when we square root, we're going to get H equaling 120. Okay, so I know that this is 120. Now to find letter P. P is on the outside part. P is a leg of the big triangle, which means we're going to use picture 2, which also means I need the total length of the hypotenuse. Okay, so I'm going to use picture number 2 in order to solve for P. And picture number 2 said we needed the whole hypotenuse over the leg that we were solving for, which is P. We're going to set that equal to the leg over the part of the hypotenuse that touches the leg, which in this case is 180. Okay, so again, we're going to cross multiply to get P squared equals 46,800. And if we square root, we get P. We're going to get a decimal on this, so we're going to round a little bit. We get about 216.33. Now to find R, you could do 2 things. You could do Pythagorean theorem. We're going to do another picture 2, just so we have practice here. And again, we're doing picture number 2 because we have it on the leg, the outside leg. So again, hypotenuse over the leg equals the leg over the part of the hypotenuse that touches that leg. So the part of the hypotenuse that touches that leg is 80. Okay, because now, again, notice that's going to make up that triangle. So we're always thinking similar triangles here. Okay, so if we cross multiply, we get R squared is equal to 20,800. And again, if we square root both sides, we're going to get a decimal, so we're going to round 144.22. So we will be practicing this in class. The big thing that you need to know is that difference between the picture 1, picture 2, and we need to have those formulas committed to memory. So try and do that, maybe make some flashcards out of it, and we will work with this in class. Hope you got some information out of this, and I hope you guys have a great day.